Hello and welcome back. Today we're going to be working on comparing sets of data, and this will be done with transformation. So it says transforming sets of data by using addition. Inquiry: how can you find the measure of the central spread of a set of data that has been transformed using addition? And this is going to be actually very easy to see. All we have to do is add a slider. Now, before we get started, we're going to learn what a slider is. A slider is a variable you can adjust in the settings. So we've got our Desmos opened up here. First thing we're going to do is we need to install a slider. So to do that, let's see. They're using constant k right now, so we'll do that. Well, let's say k equals 0. And you see how it now gives us steps, gives us a less than, greater than symbol, and a step size. So this is defining k. We're just going to say -10, +10, and our step size will be 1 for now. So we can adjust this. It's just some number k. It's whatever we want. We'll just leave it as 0 right now. This will let us quickly change what we're using as a scalar or multiplier. Let's make a quick adjustment here. All right, so first word of the day is a linear transformation. And the reason why this is going to be a linear transformation on a data set, the two things we can do are very linear. So we're going to, let's say we have some data set. Things we're going to learn today is first we're going to put a multiplier in the front, or we're going to add something to add or subtract something to the back. So there's one more operation performed on a set of data that can be written as a linear function. Common linear transformations are adding a constant or multiplying a constant by every value of the data set. So a linear equation, the most basic one that we usually use, is y equals mx plus b, where the x is our unknown. Now, what we're talking about with a linear transformation of a data set, this x is going to be every piece of data. So every piece of data can get multiplied and then by a constant and added or subtracted by a constant. It's called a linear transformation because we are doing to it what we do to lines. Transformation using addition is incredibly straightforward. It says a real number k is added to every value of the data set. Let's adjust that focus. Slide that back a little bit. And then let's pull this camera out a little bit more. There we go. The mean, median, mode of the new data set can be found by adding k to the mean. Perfect. So new data found by adding k to the mean, median, and mode. Again, very straightforward. The range and standard deviation do not change. And that makes sense because standard deviation and range deals with minimum and maximum values. And if we add numbers to it or take it away, it's not really going to change much. It's just going to slide left or right. Now, when we talk about multiplying as a transformation, this will change things. So when we add, we can't add 0 because it doesn't actually change anything. And it says every value of the set is multiplied by some constant k such that k is greater than 0. The mean, median, mode of the new set of data can be found by multiplying each. So mean, median, and mode. Of the new data set can be found by multiplying each original statistic by k. The range and standard deviation of the new data set can be found by multiplying by k as well. So range and standard deviation of new data, new set of data, found by multiplying each the original statistic by constant k. I'm not highlighting every word, we're just highlighting words to try to really make it pop out to us. Range and standard deviation of new data set. All right, so let's do some practice. Here they give us a data set. They want us to find the mean, median, mode, and standard deviation. All right, so I'm going to add a table. There's my table. We're going to enter our data. 8, 11, 3, 6, 15, 3, 5, 7, 14, 3, 5, and 4. Now we need to do mean, stats. Now we'll do sort. Median x1. We have standard deviation x1. Actually, we'll get rid of the median. We should use the stat command. The stats command has the median and the min and max for our range. All right, so our mean is 7. Our mode, let's look at the 12 elements. 3 is our most occurring number. Standard deviation, 4.22. The median is 5.5. And the range will be 15 minus 3, which is 12. It then says add 6 to every value. All right, that's no problem at all. 7 plus 6 is 13. 3 and 6 is 9. Standard deviation does not change. Median plus 5 will give us plus 6 is 11.5. And the range will still be 12. Now it wants us to add k to each value of the data set and see what this does here. So what we can do now is I'm going to go to the mean. I'm going to write plus k. Our k value is still 0, so nothing's going to happen at first. Plus k, plus k, plus k, plus k. All right, nothing has changed. Now we're going to change our k value to 6. What this is going to do is it's going to add 6 to every piece of data. So slide that to 6. And let's check. It says the mean is 13. Yep. So the mean is still 13. Awesome. The mode is 9. Standard deviation is still 4.22. Oh, they're having us do this manually. 8 plus 6 is 14. 3 and 6 is 9. 14 and 6 is 20. And then the last one is 10. Our median is going to be 11.5. And the range is still 12. So it gives us a very easy way of doing this on Desmos because all we have to do is use our addition step inside the function and it handles it for us. Desmos is smart enough to see that when we say plus k, it's going to take whatever we make that constant and add it to each number. Transformation using multiplication. Find the mean, median, mode, range, and standard deviation of the data set obtained after multiplying each value by 4. All right, so I'm going to set k back to 0 because if k is 0, it doesn't change anything. Our data is all back. All right. Now what we're doing is we're going to be setting this up to be the easiest way to do a linear transformation. Putting in our new data set, 12, 18, 20, 12, 14, 18, 11, 21, 13, 18, 11, and 24. All right, taking a look, says mean is 16, our median is 16, our mode, most occurring value, is 18, range is 13, 24 minus 11, yep, and standard deviation is 4.2. All right, so they're doing some rounding, and this is one of the big problems that you will always have whenever you're doing work with statistics. So we've plugged in our data. They have 4.2. Our standard deviation is 4.39. The reason why theirs would be different is they are probably rounding after they've calculated the mean. They do their subtraction in square steps, so there's probably some rounding going on. Our standard deviation is the most exact form we can get, so we're going to go with that. And you will not be marked wrong if you use Desmos for standard deviation and the number is different. All right, now we're going to multiply the measures of central tendency and spread by 4. So we can multiply each one by 4 individually, but on Desmos, what we're going to do is add a new slider. This will be m equals 1, and we're going to start from -10 to 10 with a step size of 1. And the reason why I'm making m equal 1 is when you multiply anything by 1, it doesn't change. So now what I'm going to do is in Desmos, I put an m and then a multiplication symbol before x1, our list. And the reason why we're doing this is this will now allow us to adjust our multipliers. All right, it says multiply by 4, so we're going to set this slider to 4. All right. It says the mean is 64. And 16 times 4 will be 40, and 24 is 64. Hey, it worked. Median is 64. Awesome. Mode 72. Let's take a look. The mode is 72, correct. The range 96 minus 44. That'll be 52. Multiply this by 4. That'll be 40 and 12. Yep, 52. And standard deviation by 4 should be 16.4. Standard deviation. Ooh, this is where it's a little bit different. Oh, because theirs is calculated differently. Yeah, so the problem is their standard deviation was calculated with less certainty than ours. So when we multiply, theirs will be different. So again, please just go with what we have on Desmos. Check, find the mean, median, mode, and standard deviation of a data set after multiplying each value by 0.6, round to the nearest tenth. All right, so they give us a new data set down here at the bottom, and we need to find mean, median, mode, standard deviation, and range. Right? Oh no, yeah, mean, median, mode, range, standard deviation. All right, so we're going to come back up here. First, we have to, let's make our slider back to 1, so it's not going to change anything. And let's delete this data. All right, put in the new data, 45, 33, 43, 51, 39, 48, 34, 39, 47, and 44. Now they want us to have a multiplier of 0.6, so we actually need to modify this. We're going to put our step size to 0.1. This will let us use decimals. So we'll go to 0.6. We can just enter 0.6 now. Bam. Mean, 25.38. Median, 26.1. Range, That'll be 30.6 and 19.8. So that'll be 10, 10.8. Yeah, 10.8. Mode. To find the mode, we have to open up our sort command. The most occurring value looks like 23.4. And the standard deviation is 3.57. Oh, it said to round to the nearest tenth. So our standard dev should be 3.6. Moving right along. The next example, they give us 3 different data sets. All right, let's get this adjusted so we can see it with our Desmos up. The number of customers eating at a restaurant during breakfast, lunch, and dinner each day is shown below. Construct a histogram or box plot for each data set, then describe the distributions. All right, so we can do this pretty easy on Desmos with our box plot and histogram commands. And again, on Desmos, we're just going to use box plots to find out distributions. It's much easier than to use the histogram, because with a histogram, you have to decide your bin size. So all of these are pretty symmetric. High in the middle, goes lower on both sides. So this one is symmetric. Going down here, it says method 2, use the box plot. And when we plot all these on the box plot, we see they look pretty symmetric. Their rectangles are about the same size. They have about the same size whiskers. There's no skewness. So yeah, symmetric. From here, we gotta make our adjustments. There. Compare the data sets using means and standard deviations. So all the distributions are symmetric. Since they're symmetric, we have to use the mean and the standard deviation to describe their centers and spread. So we have 59.8, 102.7, 77.4. Our means are kind of sporadic. They're different numbers, but if we take a look at our standard deviations right here, they're all right around that 8.3 area. So that's actually pretty nice. That means even though we have different numbers, the average or the likelihood that people come in and out are about the same. So it's always like plus or minus 8 people. That's pretty consistent business across the board. The means vary, with breakfast having the lowest average number of customers and lunch having the highest. However, the standard deviations are approximately the same. This means that while the number of customers for each time is different, number of customers for each time of the day is different. I guess you'd say like the average ups and downs is about the same. So, yeah, I mean, everything's about plus or minus 8. That's actually pretty good.
Please excuse the interruption. Attention.